The worldwide acoustics market is expected to reach $17.3 billion by 2027. This is a fast-growing market, and Frankie and his team are trailblazing with their playful and inspiring sustainable acoustical solutions. With a multicultural pedigree from South Africa and Dubai, I wonder what are the qualities needed to design in this space, and are different design solutions required for different countries and their cultural and climatic differences? Let's meet Frankie with the answers. Welcome to the Design Royalty podcast.
Thank you for having me. Thank you very much.
So excited. I have never met an acoustical designer. Is that your
That is pretty much what we do, yes. We design acoustic products for architectural projects.
I need to know everything. But first of all, the format of the show is an icebreaker.
Right.
Have you bought anything?
I have indeed.
What have you bought?
It is a model aeroplane. Design was never my first choice of career. I wanted to be a pilot. So growing up, through my teenage years, I wanted to fly commercial airlines, and got into design through my dad, which did exhibition design, which strangely enough was actually involved with an aviation company. So I used to go to all the air shows with my dad, designed exhibition stands with him, built them, and that's how the progression went from wanting to be a pilot into design. It bit. I absolutely loved it, and been in it ever since.
So did you actually train as a pilot? Or it was just a passion?
I did, yes. I didn't do, sort of continue with it as a career, but I did. I did some ground schooling, did some flying, and unfortunately that sort of slipped away after a couple of years.
But it brought you towards your project, your passion.
It absolutely did, yeah.
Fascinating.
So, can't complain.
Fabulous.
Yeah.
Another thing I find fabulous is your surname.
Right.
Your full name, please pronounce it yourself.
Francois Donald Papastefanou.
That needs to be in lights.
That's why everybody calls me Frankie. It makes it a lot easier.
Where does it come from? Where does it originate from?
So I was born in South Africa. My father is Cypriot. So the Papastefanou surname is Cypriot. Still visit Cyprus all the time. Absolutely love it. Francois is just generally a very common South African name. And I'm actually one of a triplet as well. So yes, my parents had to somehow get all these names put together, and I ended up with Francois.
So you're a South African Cypriot.
Yes. Who
also relocated to Dubai.
Yes. Yep.
Multicultural.
Yes, absolutely, and loved it. Moved to Dubai in 2007. Worked out there for about 9 years as an architect, interior architect. Worked on multidisciplinary projects from architecture to interiors to lighting to acoustics, and that's pretty much how the industry is these days. It's more a design collective, so many different disciplines within the sort of architectural industry, and you sort of find yourself working across all those disciplines.
Specifically in the acoustic design sector?
No, it was more sort of general architectural projects. But as part of that, you need to bring in lighting design and acoustic design, health and safety, civil defense. So you get to know all those different disciplines as you go along. A lot of the bigger projects also incorporate specialists within each of those disciplines. So you've got a fire engineer or an acoustic engineer, but your general knowledge through all those different disciplines, it's all there. And I think working in different parts of the world sort of exposed that.
So we've heard about your passion, your original passion to be a pilot, transferred into the design arena. How specifically did you fall into acoustic?
Well, again, it's a very interesting, it was almost an evolution. So working as an architect, often when you specify in products, you just can't find what you're looking for. So I would very often, and maybe not in the beginning specifically with acoustic products, but would sort of design something very specific for something else, maybe a piece of furniture, a ceiling design of some sort. And it was all more an industrial design kind of direction, bringing in all these things specifically for different projects. And acoustics was one of them. So sort of designed a couple of products, and totally by accident, I came across PET. I was visiting Cologne for one of the furniture fairs, and there was a company there introducing PET, which is recycled plastic bottles, which is then pressed and it forms an acoustic board. I saw this and thought, you know what? Some of the products that I've put down on paper, this could work really well for. So got a couple of sheets in, had a look at it, experimented with it a bit, and that's what really sort of got me looking at designing acoustic products. And again, you know, some of the products out there were fantastic, but just almost lacked a bit of dimension. And that's where, you know, sort of really could express and experiment with different things and create three-dimensional acoustic products for ceiling systems and things like that, just adding to the overall feel and comfort of a space.
And fast forward, now you have set up your own design studio.
Yes.
Specifically for acoustic design.
Yes. Well, again, for acoustic products to be used for architectural projects.
Am I saying all the words correct?
Yes, absolutely.
Right,
Yeah,
okay.
no,
Because-
everything's...
Yeah, okay, because
Yeah.
my background is property. And for me, you know, 30 years ago when I started developing houses, we used to put, you know, the Sonos, the equivalent of the Sonos,
Yep.
and that was the surround sound experience.
Yep.
And now, you know, it's just, I mean, you tell me. I mean,
Yep.
what's the most progressive product that you deal with on the market
Ooh,
today?
wow, okay. I mean, look, acoustics ranges from floor applications, wall applications, ceiling applications. Ideally, I think we have focused very much on ceiling applications. So in an architectural project, I mean, obviously the trend these days are these large open spaces, exposed soffits, you know, no ceilings. But that comes with a price. It really disrupts acoustic performance. You get a lot of reverberation. So the sound is just bouncing off all these.
And that's not good.
That
Reverberation is not good.
Absolutely not.
Right.
What happens, it amplifies and it bounces, and, you know, it makes speech and things inaudible. It just doesn't really make a space very comfortable. So bringing in acoustic products, specifically PET like we use, there's many different products out there that you can use.
And your PET, that's the recycled plastic?
That's recycled plastic
Ooh,
bottles.
so it has
60% recycled plastic bottles. 60%, yeah. And the product
Congratulations.
itself, thank you. And the product itself is fully recyclable. So
Is this a patented product?
it's, you know what, that's a really good question. I think part of it is, yes, but there's various companies manufacturing it. So we, as a design studio, we don't manufacture the product itself, the actual raw material, the sheet. We use that sheet and design our products with that. But yeah, you know, when it comes to sustainability, which is, you know, it's all the talk these days, you know, around projects. This just fits into that little bracket really, really nicely.
But before we talk about sustainability, I want to understand. So your product primarily is something that we fit into the ceiling part of our building.
Yep.
That has an effect on the sound quality within a room
Correct.
and a space.
Correct. So when we talk in acoustics, we got two different things that we need to consider. First thing is attenuation, which essentially is how sound...
I've never heard of this word.
Oh, right. Well,
Attenuation.
Attenuation. So we get something called room-to-room attenuation. And that essentially is the sound traveling from one room through to another. So if you could hear, I don't know, somebody speaking on the other side of the wall,
I can.
that is very poor acoustics. So there's no the attenuation, room-to-room attenuation is just, it's not working. So there's various ways to resolve that. That comes to the construction, or there's a wall assembly, you know, soffit to slab walls, rock wool inside, you know, various things, multi-layer plasterboard. So there's various ways of doing that. So that's attenuation. Then you...
So you're not actually, so it's an interesting point. So your acoustic design is not actually bringing noise into an environment. It's also eliminating noise.
Yes, yes. And our product really focuses on the second part of understanding acoustics, and that's reverberation. And that is essentially how sound bounces off surfaces within a room. So if you're standing in an empty room, you've moved into a new house, and you're standing in that room and you talk, everything, it sounds very echoey. Now, our products and the PET material that we use reduces that echo or the reverberation.
Well, why do we care?
Because it just doesn't sound very comfortable. Would you like to, our conversation we're having right now, if we were hearing our own voices echoing back to us, would it feel very comfortable?
No, very good.
Absolutely.
I like that example. Yeah.
So,
and also, I've read, I researched here, a whisper is 30 decibels.
yes, yeah.
So we have to strain to hear that.
Yeah.
And then a motorcycle is 95.
Exactly. A lawnmower is about 90, correct.
But
yes.
I mean, I don't know these things other
Yep.
than researching
Yep.
them. But obviously, our body maintains some sort of equilibrium and gives us a poke when we're uncomfortable.
Absolutely. And, loud sounds aren't necessarily a bad thing. They, an explosion goes off, your body notifies you, there's danger nearby, So loud sounds have their place. And decibel essentially is the intensity of sound, how loud an object comes across. That would be the decibels.
And your work is designed to create the optimum sound level?
I wouldn't say so much sound level, but it's the acoustic comfort within a room. Again, we go back to the reverberation, and essentially our product is based around reducing reverberation.
Give me an example then. What is the environment that you would say has perfection?
Well, theatres, I would say, there they've got acoustic technicians coming in, working on
old theatres or new theatres?
I would almost say both. They've
Both
got a slightly different feel and character about them. So, yeah, I mean, obviously nowadays with modern technology and measuring equipment and things, the amount of effort and the amount of sort of data that goes into determining what makes a good theatre acoustically, there's guys that will spend years studying that and understanding that to get that right. And, we talk about reverberation and say we want to reduce that. We don't necessarily want to cancel it out. You still need a certain degree of reverberation occurring within a space. Otherwise, it becomes dead. And you can almost feel your ears almost humming if a space is too dead from sound. So, yeah, there's various ways. So you've got to find a balance between it all.
Hey there! If you're enjoying this episode and want to hear more exciting and informative chats about design and architecture, then don't forget to subscribe and leave us a review. We'd love to hear from you. Anyway, back to the episode.
What's your favourite project that you've worked on, or your favourite type of acoustic project?
Wow, it's a difficult one. Each project offers a very unique approach. A lot of our products are modular, so we can essentially put them into a space of 10 square meters, 100 square meters, 1,000 square meters, whatever the case may be. It's interesting. It's difficult to really pinpoint a favorite. We've put our stuff into universities, restaurants, office spaces, various things. So each of those projects comes with a very unique experience, and our products are part of that. We work with architects and designers designing those spaces. It's not just, we need to reduce the reverberation, let's just throw something in here. We work very closely with them to determine the right product for that space. So no, every space is unique and exciting, challenging, and that's what we love about it.
There's an example, and I've written it down and I forgot it. The Whispering Gallery in St. Paul's Cathedral.
Oh, right, yeah.
Have you ever been in there?
Unfortunately, no, I have not.
That acoustic experience is incredible.
Yeah.
For me, because it's an existing 100 years old building.
Yeah.
But how they've managed to create an environment where actually if you're over there,
you can hear it all the way on the other side.
All the way on the other side.
And this is, again, all about acoustics. It's how the sound performs within a space. So we've spoken about attenuation, we've spoken about reverberation, but sometimes you want that sound to travel, and it just depends.
Why?
Depends on the space. What are you trying to achieve in the sound? Obviously for a modern day office, you want to keep the reverberation quite low. St. Paul's, I think, is unique, and there's various things. I mean, domes, it's not just surfaces, it's how those surfaces are actually designed, their shape, their form, that determine how sound is going to perform within that space. The Whispering Gallery, unfortunately, like I say, I've never been, which I need to rectify.
Yeah.
There's various ways of treating sound.
Also in Estonia, have you heard about the forest megaphones?
No, I have not.
Yeah, giant megaphones made out of natural wood.
Okay.
Yeah, that magnify sound right across the valley in the area.
There's so many interesting buildings all around the world, especially sort of older buildings where, before we had PET and had stretch fabric and all these nice sort of, materials to treat acoustics or how they perform. And that was all relied on in those days, with natural elements and more around the shape and the form of buildings and spaces.
So I'm hearing from you that the shape and the form of a building or a space affects the acoustics. Yes. And I understand that, is it a rectangular building or a square building is the optimum space for a designer to work with? It gives you an opportunity to create the optimum acoustical experience.
Well, okay, that's a very interesting question. I wouldn't say optimal. It could be. It's just obviously that footprint is geometric, so you can cut it up and divide it up equally. Something quite interesting. Once you start getting little pieces jutting out, and it starts complicating a space because now you're working, with certain little elements that might be a bit awkward. I suppose as a pure geometric form, as a footprint, yes, it could be quite optimal.
But you are not space discriminatory.
No, I would no.
That's what I'm hearing.
No, absolutely not. And going, when I talk about form and how it affects acoustics, even with some of the products we design, it's the same thing. So we get our PET as flat sheets. So what we do is we create three-dimensional forms, domes, and things like that. So the more angles and facets you can create within a product, the better performance you're going to get out of your acoustic product. Because sound is basically, part of it's absorbed, part of it is deflected or reflected. And the more you can break up those sound waves, the quicker they dissipate. So you're actually improving the performance within that space by having this part of it absorbed, part of the sound absorbed, and part of it deflected into different directions. You're breaking up the sound waves.
So give us an example that we might have seen in a building of this multifaceted object that's absorbing like a sponge. Like the Royal Albert Hall. Have you been inside that building?
Oh, you're going to ask me all London? These questions of places I haven't been.
All right, Dubai. Where do we know in Dubai?
Where do we know in Dubai?
If we don't know, we don't know.
We don't know. Look, I think to put it in terms, I can't pinpoint a specific space in London where you do that, but
you create these objects.
These objects, exactly, with different angles and different facets, sort of bouncing and deflecting all the sound in different directions. For argument's sake, one of our products, Harmony, it's an acoustic dome. You can put a light in it, or you could just have it as a dome over a table for acoustic performance. But essentially, it's based on a dodecahedron, which is one of the plutonic shapes of the world. Yes, it sounds very, very fancy.
Like
but
Superman.
Yeah, it's a soccer ball, essentially. A soccer ball is a dodecahedron. So it consists of facets of hexagons and pentagons all put together to form a round object. So we've essentially cut that in half. But all those angles that you've got are all different. And as sound sort of comes into that dome, it absorbs some, it deflects some, but it's deflecting it in different directions, and almost again deflecting it into another face or facet, which again absorbs and might deflect some. So it just continues breaking up of the sound.
Were you a whiz kid physician at school?
Absolutely not. No.
Because physics is part of this work, isn't it?
To a certain degree, yeah. But I mean, essentially, it's design. I don't put too much science or scientific thinking behind it. Yes, talking about a dodecahedron, it's a plutonic solid. It's not a new shape. It's been around for generations. It's there. It's just we find interesting ways of manipulating a flat sheet of material into three-dimensional objects.
Have you read this month's issue of Designer magazine yet? Available in digital and print editions, Designer magazine keeps you updated on the world of design and architecture. Get your free trade subscription today at designerarty.co.uk.
What's something? So, for example, when Elon Musk bought out the Teslas.
Oh, yes.
Yeah,
Yep.
he re-engineered and disrupted the whole automobile market.
Yeah.
What's going on with your market?
I think it is changing. I think a lot of the products we've tried to be different. Acoustic products are not new. PET is not new. Acoustic wall panels are not new. We wanted to do something different. So it is an evolving market. I think there's a lot of companies that are getting a little bit more daring with it, finding new ways of manipulating the material to create different objects. So yeah, it's an ever evolving, and this is the beauty about design, architecture. It's ever evolving. Nothing ever stays the same. Philippe Starck once said, every line has been drawn. But I suppose the question has it. You may take a line that you've seen and manipulate that into a different line. Does that mean it's been drawn before? Probably not. So yeah.
What's your starting point for your process, your design process?
It's always an interesting one. Sometimes we just get a brief. So we get a client approaching us and say, right, we've seen something that we like. It may necessarily have nothing to do with acoustics. It's just a shape or a form that they've seen done. So we really like something like this. And that, from a strict sort of client brief, would be the starting point. Right. How do we create something from what they're showing us?
So the starting point would be the product as opposed to creating an experience or an ambience within an environment?
To a certain degree, I think both need to be considered throughout the process. At the end of the day, the reason we're putting this product in there is, yes, for performance purposes, but also from an aesthetic point of view. It needs to be an integral part of the overall design that the architects are bringing in. I don't know. They bring this beautiful design of an office, for argument's sake, or a restaurant, and we go and slap in bright pink, sort of baffles or something. It just doesn't work. So it's this constant collaboration between the client, the architects, ourselves, to get to an optimal point that is both aesthetically pleasing, complementary to the space, and adds the acoustic performance. So it's function and form that all need to come together. Mm-hmm. A lot of the products when we're designing ourselves, I might just wake up one morning and walk around and see something that just almost inspires you. It may necessarily mean absolutely nothing, but
what inspires you?
Generally or product wise?
I like both.
Both.
Yeah.
Both. Well, product-wise, there's nothing specific. Like I say, sometimes I walk around and you might even see a shadow, sun reflecting off something. It sounds a little bit cliched maybe, but, you suddenly think, you know what, this could work. Or you're thinking, from an architectural point of view, you've got these really nice architectural beams. How can we convert that into an acoustic product? Yes, it's not going to be structural, but from a look and feel, and from a performance point of view, that could be really cool. Acoustic baffles that look like beams, and then you sort of draw it up and do your thing and develop it and prototype it and bring it in if it all works. From a life inspiration, again, I don't know. It's difficult to say. It really is. My son definitely. Gives you a reason to wake up in the morning.
How old is he?
He is 7, going on 8.
Oh, wow.
Yeah, and already following in my footsteps. He loves technical drawing, and sort of work with him on that. So I think it's just wake up and have that sort of positive attitude every day and, get on with things. And I think that's what design is. It's creativity. If you sort of got yourself in the doldrums somewhere, you just don't feel inspired. You don't feel creative. You don't feel motivated. And
you have
I think
to
it's
watch
a
your
mindset.
energy and your mindset.
Yeah,
I'm always fascinated by how people create something new, because how do you know what you don't know?
Yeah, no, absolutely. But that's the experience. I think that, again, for me, design it's experience. And I don't mean experience as in, years of experience. I mean the experience and the interactivity of creating something. Is this going to work? How's it going to work? How does it fit together?
Interesting.
Things like that.
So maybe taking risks and not always winning, sometimes failing.
I think I've got an archive of designs that never worked. But you try them out, and you pull them up in 3D software, and you can see what it would look like before you've even prototyped something. And that's part of the journey. You don't always get it right.
What software are you using?
So I mainly use Rhinoceros, which is the 3D software, and then AutoCAD as well. We get a lot of our client drawings on AutoCAD, Revit, and things like that. So, but mainly our primary one that we use is Rhino for the 3D applications.
And when you're looking for recruiting into your business, what qualities are you looking for?
Again, I think it's somebody that just thinks a little bit differently. Graduates or somebody can come to you with a great portfolio, and you can have a look at it and like, oh, this is amazing. You did this project, But I think it's how they incorporate. I think we're about a bit of a culture as well. It's about personality. And somebody can have this amazing resume, but they just can't work in a team, sort of loners or something. So we very people orientated, and when we're looking for somebody, it's that same quality. Obviously be able to work on software, anybody can learn that, but it's like, how do you interpret things a little bit differently? How do you just take for argument's sake, in our industry specific or our business specifically, take a flat sheet of material and create something interesting? How do you translate that to other people? I think it's more about attitude.
Attitude, interesting. Yeah. Noise is fascinating for me because I'm a visual person, and I just wonder if there's any science about how important acoustics are. I had an MRI scan yesterday.
All right.
And one of the things I noticed was the ridiculous noise.
There's sort of a humming.
Yeah, and I was also mindful. I was interviewing you today, and I was thinking, why have you not been invited, or your company, into the NHS to resolve this problem? I don't want to hear this humming noise.
Yeah, well, this is the big thing. I mean, you walk into so many spaces, and I dare to say it. If I get into trouble for it, so be it. But even coming through the front door this morning, downstairs, the acoustics in there are terrible.
How so?
Well, it's just that reverberation. There's so much echo. And somebody sitting on that side of the room, you can hear their entire conversation because it's just carrying across the room. There's nothing in that space absorbing any of that sound.
And I'm guessing that affects the quality of the meetings.
Absolutely.
Our well-being.
Absolutely.
Our attitude.
Yeah, absolutely. And it's the same thing in schools. You can imagine a classroom full of kids and the teacher standing up front there, and you've got a very echoey kind of room. By the time the child at the back has actually heard what the teacher's saying, that sound is bounced off, I don't know, tens of different surfaces, and that echo actually makes the sounds. Imagine kids doing phonics, and it's very specific how words sound and how they get put together. If the child isn't hearing those phonics correctly, they get it incorrect. Now, when you've got really bad acoustics and a lot of reverberation in a room, the sound that they're actually hearing could be totally different to what the teacher's actually saying. So it's got a massive, massive effect on school kids in bad acoustic environments. And the same thing, like you mentioned downstairs, you're having a meeting. It's distracting. You're hearing things from all over the place, just sort of bombarding you.
And going back to the point, the stuff we don't know.
Yeah.
sitting downstairs in that space you're talking about, I commented to one of my colleagues how I wasn't feeling comfortable now. I was thinking in my head, is it because I got up at 5 a.m. this morning? Is it because I didn't like my pret-a-manger sandwich? But actually, I think
it could be
the reverberation.
Yeah.
Can you make an app, please?
an app.
Yeah, a reverberation app, so that people like me who don't know what's going on all the
Can
time
quickly take a little
we
reading.
can like shamaz it.
Yeah.
And then we'll get an
Yeah.
environmental
Well, you see,
sound check.
There again, it's almost not even necessary because it's how you feel when you walk into that space audibly. I mean,
But how do I know it's noise that's contributing to my... I thought it was my pret-a-manger sandwich.
do you feel comfortable sitting in a space where you're getting a lot of bouncing around sounds? Like downstairs, for argument's sake. You've been through that space so many times.
Don't feel comfortable.
No, exactly.
But didn't know it was the noise, which is why
it's the noise.
I'm wondering how aware people are of the necessity for an acoustic designer.
Probably not at all. And acoustics really, from architectural projects, have only really come to the foreground in the last couple of years. It was never a serious consideration. Okay, we designed things differently then. We had false ceilings and we didn't have exposed soffits. We had closed cubicles. Thank goodness all those times have gone. But that's how offices used to be. So there wasn't really, there were a lot of soft surfaces able to reduce the reverberation within those spaces. But with the design trends now, it's all changed.
So it's an exciting sector that you're in, because I feel this is up and coming.
Yeah, it absolutely is.
Yeah,
it is.
You're about to take over the acoustic design market.
Well, yeah, we're going to give it a good go.
So talk about your product. You're talking about this PET.
The PET. Yeah.
Yes.
Yeah. So, like I said, it's essentially plastic bottles. Plastic bottles you drink water out of.
But this isn't an atypical product to use in acoustic design, is it? This is something...
It's become a lot more frequently used over the last couple of years. So the common way that acoustics used to be addressed was fabric-wrapped panels with maybe an acoustic absorber, a rock wool or something, insulation.
Or egg... What are those egg carton things?
Oh, yes. In fact, they are very good. And just an egg carton is actually a really good acoustic product. And that's a good one to bring up. So first of all, the sound gets absorbed by the mache that they use to create it. It's porous and the sound can actually be absorbed by that. But also the different angles. So it's actually got the little cones, with the X-fit ends sticking out. And that, again, what I mentioned earlier, how the sound gets broken up.
Multidimensional.
Exactly. When the sound hits that, it breaks it up and bounces it off in different directions, which dissipates it quicker.
We are stuffed in this environment. There is no multidimensional aspects of this wall.
No. We could do something with that wall.
What would you do?
Well, we've actually got some really nice three-dimensional wall panels. And again, this is the thing. So while we're on that, so it's wall panels, but they're three-dimensional. And we've created a series of parametric blades that sort of stick out and then have got a shape to them. So the sound sort of moves in between these blades and gets absorbed in there. So acoustic performance is absolutely brilliant.
When you create your app for the environment checking,
we'll do that.
If you can just have an acronym section as well.
Oh, really? Yeah.
There's words that I'm hearing
that
that I have never heard in my life before, and I'm wondering.
Should I write them down?
Yes. Yes.
You know what? It honestly sounds a lot more technical than it really is. It's quite a basic principle. It really is.
SFX.
SFX.
What's an SFX?
I have no idea what
Forget
an SFX is. No.
DAW.
What are we talking about here?
GIT.
GIT. It sounds like a second-hand car.
Or an old kit. SVN.
SVN.
When I was researching your sector, there's all these acronyms. This is clearly the wrong.
You see, these are things you might find with an acoustic engineer. It goes a lot
What is
deeper.
the hierarchy of your workplace then? So where does an acoustic engineer come in the design process? Can you explain that to it?
So we would get, in fact, I had a phone call this morning from a new client, which is an acoustic engineer. And
so they're your clients.
so they're busy on a project, so they would be the client. So what he phoned me for, the information he required was, what is our NRC rating on the material? Now, the NRC rating is your noise reduction coefficient. That essentially is how the sound and how much sound is absorbed by the material. So they take that information and then they do their calculations. So they would have, let's go back to your optimal rectangular room. That is the floor plate they're working with. They would then take that. They would then calculate the square meterage of material that we're using, take that NRC rating and work it into their calculations. And from that, they could then determine, right, we need X amount of this material in this space to get the NRC to this level.
So it's very much you collaborating with the acoustic engineers. That's the relationship.
Yes. So I am not an acoustic engineer. That is a totally different...
And that's clear because you didn't know the acronym.
Yeah. They are totally different, not field, but they are specialists in...
They're complementary to your...
They do calculations and all kinds of things. We, as a design studio, use an acoustic material to create acoustic product that these guys would then specify into projects.
What are you most proud of that you've designed?
Again, it's difficult because, it's almost like little kids. You're creating these things, and they all got their special little place. But one of our most popular products, Dew, is almost resembles a little kid's little plane thing. So it's like a round disc, and it's got little friction slots, little holes, little slots cut into it, and you piece it together. So one of our products, Dew, is probably our most popular one globally. And when I first did it, it was totally by accident. I actually designed those little pieces as connectors for a different product. And then one night was sitting and had a whole lot of the spare ones left, and started piecing them together. I was like, you know what? This is quite cool. So, it's not always a specific, sit down session, let's design something. Sometimes it's totally by accident. You just got to almost recognize that moment and think, wow, what can I do with this? There's various things.
And what's the purpose of that product?
That is specifically for a ceiling insulation. So it gets suspended from ceilings. And once assembled, it actually gives an effect of almost foliage, like trees, especially if you do it in like a green color. And it just gives a very nice kind of flattery effect in the ceiling, a very interesting ceiling landscape. But the acoustic performance on it is outstanding because all of those pieces fit together at different angles. So you're just getting, and the sound gets trapped in there, you're getting the sound traps. It's an amazing little product.
That's incredible, because for me, when you talk about it, it almost sounds like a complicated algorithm has been created.
No, not at all. And in fact, if you had a look at a finished product of ours, it does look very, very complex. And you know what? It went through its fair processes when being designed. You've got to work out how the friction slots work together. Everything's got to fit together. But they're easy to assemble, they're easy to install, and they're quite intuitive, to be honest.
And also, the trend at the moment, one of the trends is biophilia.
Yes, absolutely,
in offices.
Absolutely. Which is also an acoustic product. Biophilia offers a lot of acoustic performance, well, to a certain degree, not on their own, but they offer a lot of acoustic performance within a space.
Carpets do as well, don't they?
Carpets, any soft fabric material. I mean, even people in a space offer to the acoustic performance. So the clothes we're wearing, if this room got absolutely filled, like take out everything in this room, just leave four blank walls and put 100 people in here, you probably find the acoustics aren't that bad.
Is there a difference in skill that's required to fit acoustics in a new build versus an existing building?
No, not at all. No. With a new building, you often can manipulate, if you're working with the MEP engineers and the architects, you can manipulate, for argument's sake, where you've got fan coil units. So your general services that are sitting in the soffit can sometimes get in the way. So you could still do a design and work with them to either move things around, or you can manipulate your way around them and things like that. When you're coming into an existing space, you pretty much, that's what you got, that's your canvas. work your way around that. So
And add things to it.
Add things to that. It's normally quite difficult to have things moved around. So, yeah, they both offer their own little challenges. But at the end of the day, whether it's a new build or an existing one that we're putting product into, we find a way, and we work with the architects and the clients to make sure we get there.
Have you got an award-winning design? Every year we host the Designer Awards, where we celebrate the very best in design and architecture at a swanky venue in London. Find out how to submit your entry for free at designerawardsuk.com. Best of luck!
White noise, is it actually a thing?
Yes, it absolutely is. So essentially what white noise does is it introduces sound to reduce sound, if that makes sense. So let me explain that. So we ourselves don't particularly work with white noise. It's a white noise system gets installed into a space, normally inside the ceilings. So it would create a sound like a low humming sound, a low frequency humming sound. But essentially what it's doing is it's drowning out other reverberating sounds of people talking and things. And most of the time, you wouldn't notice it's there. But
oh my God, I need that in my ears permanently.
But it's on in the background, and it actually physically makes a noise. It actually physically is making a noise in order to drown out other noise.
Love it.
Yeah. So yeah, white noise is a thing.
So do we have any, for anybody interested in creating like the optimum ambient environment, is there any science or any papers we can direct people to go to if they want more information about this?
Absolutely. I mean, Google's a friend. You can get so much information from Google. We offer CPDs as well. So we actually go out to architectural clients and things, and we do CPD. So we do a run through of all the basics of acoustics, what they need to understand. Obviously, again, that isn't to this, the technicality of an acoustic engineer, but it's not necessary. They don't need to go and make acoustic calculations when designing a project. So yeah, there's a lot of things available on the internet, our website. And like I say, we offer CPD, so we often go out and see clients and present product and just have a bit of a talk about it.
I'm curious about the geographical differences that create a difference in sound requirements. So, for example, when I'm in Dubai, it's very noisy and chaotic, and I wonder if culturally their demands are different than maybe in the UK.
Well, look, I don't think culturally very, very different. Yes, it's a little bit louder if you go out to places like that. But again, that could really come down to the acoustic design within the space that you're experiencing that. Having worked in Dubai, having worked in the UK, having worked in South Africa, and even working out in the US, a lot of our product is sold out in the US. Most offices are designed the same way. The same products are put in to a certain degree, and the same result is required. We need a nice low sort of sound level. We need it comfortable. You mentioned Dubai, and you look at the UK and you look at Dubai. You even look at the weather. Even weather affects sound.
How so?
So sound travels further in the cold. So if you were out at night, out in a field, and you heard, for argument's sake, say a gunshot. You heard it miles away. You could probably hear that a lot further away in colder weather, because essentially in warmer climates, the warm air rises and it actually affects the sound waves. It actually sort of elevates them. It moves them up, so it might shoot over your head, kind of thing. So you hear better in colder weather. So
also across water.
Yes, water is one of the best conductors of sound. Yes, submarines and things all use sonar. They're using sound to detect underwater anomalies or whatever it may be. Submarines and ships, and so yes, sound travels extremely well through water.
Where does your company name come from?
So 1468, when we were trying to decide on a name, we wanted something, again, the same as our product. We wanted something different. We wanted people to ask questions exactly like this. So 1468 is actually the birth years of mine and my business partner's kids. So 2014, the 14 is my son Blake. And even in our logo, the 4 is backwards to represent a B for Blake. Then the 6 is my business partner Dan, his son Jamie, born in 2006. And the I in that 6 has actually got a little foot on as a J for his son Jamie.
Meaningful.
Yeah. And then the 8 is Dan's daughter, born in 2008, Emerson. And we've essentially split the 8 so it looks like an E. So it was something close to our hearts, something personal that we wanted to bring in, but something that would also raise questions. Where does this come from? And that's
creative.
That's creative. That's what we wanted.
I just want to pronounce your name. Papastefanou.
Papastefanou.
Francois, you are a pleasure. Lacquer
Lacquer, I like that.
Now, if you have enjoyed today's podcast as much as I have, like and subscribe it, please, and join us here again every Monday with more exciting guests. See you then.